this is a mud fossil. Now, they say, well, where's the bones? Well, this is the entire organ of the bone. That's where your the cartilage is, and all of the emplacements of the tendons and ligaments, where the bone, the veins and arteries invested. Here's what happens, though, in mud fossils is where the bone would be, it's gone. And the reason for that is because these are formed in wet environments, and the calcium and the phosphates and the phosphorus and all the business that's in bones is extremely volatile to chemical invasion in wet environments. And when I say chemical invasion, you end up with this. You see that? It goes in. There's still a little bit of bone left here, but all of this stuff gets attacked, and there's different names for the different types of bonding, and there's actually other ones. It's called nucleophilic invasion. There's chemicals that come in and say, get out of here, I'm taking over. And there's other ones that come in and say, I'll work with you. You calcium, you got some extra of this, or you need some of that, and they share the electrons, and they turn into other different minerals that are primarily crystals. And eventually it breaks down to where all the weakest parts of minerals, the lowest sublimation rate, which means they go away at the lower extremes of temperature and pressure, they will go and transition into these compounds, which end up being hydrocarbons and different types of crystals. It depends on what's filtering down through here. But anyway, this is what you find in the middle, and that's why there's no bones. So if you're looking for bones, you can get them sometimes, but 99% of the time you got to really dig. So you saw what I showed you, and now I'm going to show you some other stuff that's going to make a lot more sense, I hope. All right, these are mud fossils I'm going to show you, and what I'm going to show you right now is the vascularization, and you can go find these in your own backyard. They're made from creatures that were captured in mud flows and petrified, and this was during the Great Flood. And I'm absolutely certain of this. And they are everywhere around the earth. And this is the vascularization which is inside of them. This is some of the little vascular networks in here that contain the reddish blood. Now, this is the bone area. And I'm going to sort of move this around, and you might get sick here, but stick with me. This is where the bone is almost completely changed over, and that is what happens in mud fossils. They transition from literal fleshy bone material and all that stuff, and they petrify. Now, watch this. I'm going to show you something that's extremely cool. I'm going to go to the side. Blood has obviously, oxygen gets in your blood into the hemoglobin, and that is when it turns extremely bright red. And I mean, this is nothing I'm making up. It's just fully understood. And it turns bright red, and that goes down the arteries, and the arteries are completely open in your body, and it's that reddish looking color there, that one that's in the center, but it comes down really, really red. This is bleached out blood, but this is on the redder side, and that's called FeO3+. It has 3 oxygens. Now, I'm going to move it over as it's using the blood going through the tissues. You see it starts to turn brown. See it? Literally, I'm moving across the tissues. And it's turning brown, it's turning brown, it's turning brown. It's going to get browner and browner and browner, and then all of a sudden it'll get real black. See here, it's starting to get browner and browner. It's using up the oxygens. Now it's moving into the black range. And then all of a sudden it's going to get blacker and blacker and blacker, and it's going to turn so black it'll be like the ace of spades. And there it is. You see it? And that is the side that goes back up the veins to get re-energized. Now I'm going to go back the other direction. Let me see if I can home this in a little better. But this is the process of blood in any creature that uses oxygen. That's just the way it works. And this ends up being FeO2+. And this comes back up and into your lungs and into your heart, and it pumps it back down. So now you can see the vascular network here. You see that? I'm not making anything up here. This is all, now I'm going to show you the bone. Now, this is the outside of the bone. This is what the outside looks like. Well, it's not a bone. well, this is skin tissue on the outside. You see that black and that little whitish looking, pigment looking things, little flaky stuff? That is, the black stuff is silicon carbide, silicon carborundum. And it's silicon and carbon. You're 50 times more silicon in your skin. Now the little white stuff is keratins and kerogens. And those are the fibers that actually create a fabric that it goes around your entire body. It's called fascia. And in the skin, it's just like this. Now, and here's what this looks like in its full-size shape here. Now, this was some form of a bone. I don't know what it was, a bone with all of the outside dressings that go along with bones that you'd never see on a regular bone because it's just bone. This has been transitioned. It's called mud fossils. And what happens is they turn from flesh and bones into this. Now, this was either a bone or it was a flesh. It doesn't matter. They all do the same thing. And this is what I showed you before, those little black spots with the little white flakes in them. Now, that's just the way it works in these things. Now, I'm going to show you something, some of my other pictures here. Let's see. Hold on one second. I mean, I got a lot of pictures, but this is, okay, here's one of the areas that is in this, these blood flows, and there's another one. And that one there is a petrified, that's blood. That is blood that petrified. Here's another one, I don't know what that is. But I just take all these kind of different pictures, but they're all off of, these are not just nothing. These are from creatures. These were creatures that petrified. What do we got here? Okay, there's one that's from a hole down there. Something's growing down in there now, some kind of fungus or something. That is something that a lady sent me, Becky Dorius, a wonderful person, sent me this selenite. And inside this selenite is these little white minerals and crystals. Look, you see inside there? That's all these, that's the crystallization of tendons. And those are deep inside of these things. They're not just floating around on the surface. Now here's some metals that were in a certain specimen. I can't remember what that was about. Here we go. And this yellow stuff is on all these tendons. There's a little spot that has that yellow stuff. Here's some more investments. Now this one here, you see those little flakes, so those little white crystal looking shapes? Those are the keratins and the kerogens, and those are, they're made out of collagen number 1, which is made out of mostly silicates. And collagen number 1 is connective tissue. Connective tissue, it does all the job in your body. It creates the fabric of your skin. It creates all your tendons and all that business. And the bones too. The bones are made out of collagen number 1. So what I'm getting at is this is life. We're looking at life here. This is not just rocks. This is life. And you showed us to a geologist, oh, it's some kind of igneous this or metamorphic that, or that's not metamorphic anything. You see that? Let me show you something. That right there, my friend, is a vein and an artery. There's the vein and there's the artery. That's it. Case closed. That's a vein and that's an artery. The black one is a vein which never gets back, can go backwards. Whoops, what happened there? All right, let's look at this. Let's look at this carefully. You see all this stuff here? That is the minerals of the body. Here's what happens in the body when you die. Everything that's the gooey stuff, they call it volatile organic compounds. Volatile goes away, organic bodily compounds, methanes, gases, all that business. They go. They just they sublimate, they call it. At a certain temperature, they are gone. Now, what's left? Minerals, metals, the substantial stuff. And here it is. There it is, right there. That's all you're looking at. Now, what happens to the veins and the arteries? Well, in the side of a vein and an artery, it's just like in a glass tube. And really, in the mud fossils, your body doesn't even know you're dead because you're still in a wet environment, and that thing is virtually inert. It almost doesn't. They're almost just tubing in there. And as long as it stays wet, it's okay. When it dries out, that's when you got the trouble. So they go looking in the dirt. They go looking in the sand, and you're looking in the wrong place. This is where the stuff gets preserved. Now, there's your vein, and that never can blow out. The arteries usually blow out, but this was fractured afterwards. So this got somehow, the red blood stayed in here. Usually that'll blow out here, and you'll end up with a cavity in here, and it'll turn into crystals. Or you'll see some coloration, but this is more heavily red-blooded than you normally see. The black, you always see black. And here, let me show you something. The black, you always see black. And here's what you more often see. Here, hold on a second. This is what you more often see. And I'm going to wrap it up with this because I know people get bored after a while seeing this stuff. That's the vein, and that's the artery. Now, that artery, can you see that? See the vein? See the little dot in the center and everything? What they have is clamps in them. They won't let the blood go backwards because it's contaminated, right? It's already done. It's got to go back and get recharged. And the artery, though, is a different case. When that artery comes down here, it's got all these little spikes that run off it. And they go into the tissues. And they go to tissues and they go, they get all used up and they come back over here and they say, okay, I got no more oxygen. Send me back and we'll get some more oxygen. And this, and these here, see this? That will turn red blood. If I put wet water on there, it'll turn it to red blood. It rehydrates. This is the plagioclases, which is the tendon enthesis balls. And this is one that hasn't been deteriorated, that is deteriorated somewhat. You see it? That's called plagioclase. And this is a little strap here. You see that strap? The strap comes down and it goes right in there and it implants, and that's a tendon, and that makes this thing pull back and forth into muscles. That's what it is. These are mud fossils. I got tons of them, DNA tested, blood coming out of them. Meteors have veins and arteries. Comet 67P is a tendon enthesis point. That's all there is to it. It's real. Somebody's got to look at it. But not one single person has communicated with me about this that has anything other than to say that, oh, that was a cool video. Nobody from anywhere that has any scientific research on this, it's interested at all in a scientific manner, they're just not interested. So, here it is. That's all I got.